Hello, my name is David Castillo Chamorro, and I'm going to present and talk about Cascade Control. So let's get started. First of all, an overview about what is a Cascade Control and how it differs from a single loop control system is that Cascade Control is different from single loop control, as the controller set point of the single loop control is set by an operator and the output drives a final control element, while a cascade control arrangement has two or more controllers from which one controller's output drives the set point of another controller. Or in other words, one controller acts depending of another. Like in this small example, we have a single loop controller, which only has one one controller, one set point, and it controls the valve here in this example. And in this other one, we have also a level tank, but this time we have two controllers from which the second one will work after the first controller gives its set point to this one. So finally, this one will control the valve. The controllers can receive one of two names according to their function. Primary, outer, or master controller is going to be the controller driving set point, which in this case is going to be this one, the level controller. And the secondary, inner, or slave controller is going to be the controller that receives the set point. And in this case, is going to be this other controller. So now we can see the overall view of how a cascade control diagram works. Here we have the primary controller, as I said, and the secondary controller, which is going to affect the secondary process and also the primary process. We have also two disturbances entering, and the sensors of according to the secondary variable or the primary variable. And here we have where we can see the secondary loop and the primary loop. Now to give a better example, we have a steam-fed water heater. Here we have the heater, but it is only one controller, the single loop, sorry. And in this system, it uses a traditional controller that is measuring the temperature inside the tank and comparing the measurement to a set point, and finally manipulating a steam valve opening to add more or less heat as inflowing water disturbs the tank temperature. The arrangement works if the steam supply and steam valve are consistent to produce an X percentage change in the temperature when the controller calls for a Y percentage change in the valve opening. But several factors could affect the XY ratio or the time required for the temperature to change, like a pressure drop in the steam supply line, or the valve could start sticking due to friction from use. So in order to solve these problems, a second controller can be introduced, and this is our cascade control system, which has two controllers, where the second controller is going to, as you can see here, we have two controllers, and the second controller is going to take the responsibility to manipulate the valve opening based on measurements from a second sensor that monitors the steam flow rate. And now the first controller tells the second controller how much heat it needs in terms of the desired steam flow rate. And the second controller then manipulates the valve opening in order to get the steam flowing at a requested rate. If it is insufficient to reach the temperature, then the first controller calls for a higher flow rate, or if it is the case, for less flow rate, as it can do both. The advantage is that in this system can provide a faster compensation when the steam flow is disturbed, as a single one would lower the temperature before the sensor could notice. So having a second sensor, the flow rate can be maintained quicker and more precisely, as it can be seen as whatever steam flow rate it desires, it will get. So the second controller can also shield the first from deteriorating valve performance or non-linearities in the valve's performance. The second controller might have to work harder as a result, but the first controller will never be affected as long as the second controller is able to maintain the steam flow rate at the required level. So now a cascade controller can improve performance when in one or of two cases. The first one is disturbances affect a measurable intermediate or secondary process output that directly affects primary process outputs that we wish to control. As a cascade control system limits the effect of the disturbance entering the secondary variable on the primary output. Or it can also improve performance when the gain of the secondary process, including the actuator, is nonlinear, as a cascade control limits the effects of an actuator or secondary process gain variations on the system performance. Now, some requirements for the cascade control system is that the inner loop must have influence over the outer loop, meaning that the actions of the secondary controller must affect the primary process in a predictable and repeatable way. The second one is the inner loop must be faster than the outer loop, so that the secondary process must be able to react to the secondary controller's efforts at least 3 or 4 times faster than the primary process to the primary controller. This is in order to avoid disturbances from inner loop affecting the primary process. And the third one is inner loop disturbances are less severe than the outer loop disturbances in order to allow the secondary controller to apply consistent corrective efforts to the primary process also, not only to the secondary process. Finally, some challenges or disadvantages that cascade control has is that as it needs an extra controller and another sensor, it increases the overall equipment cost. The second one is that more complex control strategy for engineers and operators alike. So it is way more complicated to use a cascade control, and it may not always be the best option. So it needs to be contemplated. And the third one is that it requires at least twice as much tuning than a single loop one. But the tuning process is pretty simple. First, you have to tune the inner loop process. And then once it is tuned, you have to put it in at work with the outer loop process, and then the outer loop will be tuned as if it was a single loop process control system. So that will be all. Thank you for your attention.